been working with physical changes and chemical changes. And today and over the next few days, we're actually going to rotate through some centers. And as you can see and look around the room, we're going to do centers. And Miss Walter's getting ready because she has her lab jacket on. So we're going to get ready to explore and have a little few days of discovery. And we're going to discover physical changes and chemical changes and mixtures and solutions. So I need you guys to help me out and refresh our memory. What is the big difference between a physical change and a chemical change? Or give me the definition of a physical change. Let's start there. Let's give me the definition of a physical change. Julia, do you have that?
A physical change is where the object, the matter stays the same inside of it. It might not look the same, but the matter stays the same.
Very good. The matter stays the same. Can anyone give me an example of a physical change, Reagan?
It's whenever you break something, like you break glass, it's still glass, but it's just broken into little pieces.
Right. So it might look different. What has changed? So if you break a glass on the floor, okay, besides crying, my glass is broken, what did you change about it? What did you change about it?
You changed the molecule on the inside, they split.
Did they in a physical? Do the molecules change in physical? No, the molecules don't change. What changed about that glass?
It just split. It's like the matter.
Right? Did the matter stay the same?
Yes.
So you just changed, you said it, I think.
Shape.
Yeah, we changed the shape. What else did we change about that glass?
Size.
The size. It still stayed a solid, right? We didn't change any of that. But it's still a glass. All right, flip that. Now we're going to do chemical change. What's a chemical change? What's a chemical change? You know the definition, Colin?
A chemical change is like where the molecules are broken up,
Right.
and it doesn't stay the same.
Very good. So it doesn't stay the same. You're going to rearrange those molecules, and they're going to split. Those bonds will break and rearrange and turn into something completely new. They don't change, stay the same. Do you have an example you're going to add to it, Owen?
I have an example.
Okay.
Burning wood.
Burning wood. Okay, so what's new about it? Why isn't it the same?
Because it turns into ashes.
Okay, and that's the new material, ashes. There's another example maybe we did yesterday that you could kind of refresh your memory, because I know we had somebody absent yesterday. Do you remember what we did yesterday and the examples of chemical? Go ahead, Nathan. Do you remember?
Rusting.
Rusting is a good one, right? I leave my bike outside for a long period of time, and that brownish reddish stuff becomes added to the metal, I guess you could say, and it becomes rust. Is there something else? Let's take one more, Spencer.
Growing mold.
Growing mold, right, because that wasn't there. So, all right, good. I know you're full of some great ideas. We're going to jump into today, and you're going to have lots of time to experiment with physical changes and chemical changes. So hopefully by the end of the next few days, you're going to have a really good understanding of a physical change and a chemical change. Think of an ice cube melting. Okay, this is an ice cube. Sit it out here in the hot sun. Okay, it's going to turn into what?
Water.
But it's going to turn into liquid. Did these change? Did the molecules itself change? No, it's still water. It's still water. Okay? Another example. How many of you have these at home? I had to bring mine in from home. What's this?
It's a sensei.
It's not a sound. It's a cheap version. Okay? Inside, I have these little things, right? Okay? It started out like this. You plug it in, add heat. What happens to my wax? It melted. Physical or chemical? Is it still? There you go. What's going to happen there? It's not going to burn, but it will melt. But it will start to melt. Remember, melting is not a chemical. Melting is it's still chocolate, but it's going to be runny. Okay? Now you know it's going to be chemical.
I think that we should use a magnet to separate the iron fillings.
Eva, we can do this. What equipment do we use for step 2? I think we should do flotation, maybe? I think we should do flotation.
Yes.
Okay. Yeah, we were correct.
I think we should do the filter. Yeah, probably.
So we can get all the water.
I'm separating the iron fillings from the sand by using a magnet.
Whoa. play these.
These are hard to put together.
Trying to get all the iron fillings away from the sand. It's gonna work.
So I'm going to need you to start cleaning up. My cleanup crew needs to help out. All right, now we're going to show you a classic example of a chemical change. I got two materials. I have baking soda and I have vinegar. And we are going to see if there is a reaction when I put these two together. Okay, so I'm going to turn up the balloon upside down, let the vinegar run, and see if anything happens here. But yeah, somebody noticed the balloon.
Oh, look at you.
Oh, yeah. So look what's inside the bottle. What happened?
It's rising.
It's not bubbling.
It's bubbling. It's what else? What other
Turning
words?
into a gas. Expanding. Wet.
Galileo's bluffing. It's just a mess up.